here. Click this one. Okay. All right. Wait for the bell to ring. I'll get started. Pull up the solutions. In a second. Almost there. What's up, Shave? All right. Good to see you. I'm glad you're here. Obviously, a lot going on right in school today with the passing of Jillian. That is going to be a tough loss for the school, but there are a lot of people here. So okay, so whatever you're going through, however you're feeling it, if you need people to talk to, I'm here. All of 119 is filled with mental health professionals to help you, and so it goes for everybody stuck at home too. That has heard the news about her passing away in the car accident this weekend. So comes as a shock, especially when you don't expect this kind of stuff. So let me know what you need. Okay, it's hard to get through for sure, but you have support, whatever that looks like for you. So so do what you can do. Today will be light. I'm going to keep it fairly simple. This is kind of one thing from 2.2 that we'll do. But I do want to check to see how 2.1 went. If you did have a chance to work on that, I do have the solution. So take that out if you've got it with you. I'll pull up the solutions for just a minute so you can take a look. Hopefully you looked pretty closely at what I wrote in the kind of the write-up for the problems. Shouldn't have been a whole lot of work. So if Wednesday went well for you, or Thursday, or whenever I last saw you, I'm hoping that you just kind of did it right away while things were fresh. You go a couple days and you don't do this stuff, it can disappear on you a little bit. So take a minute, look through them, and then we'll start and probably finish 2.2 today. It's really not a lot, which is a good kind of lesson for a day like this. So part 2 is basically pretty set in stone. There's really not much that can change, right? They gave us the function. It was just kind of up to us to write down the vertex, draw a little sketch, or you can write like opens up, opens down. That's fine too, and decide min or max. Change the sign of the number on the inside and keep the sign of the number on the outside, on the right side. Okay. Remember that a value doesn't matter for where the vertex is. It only changes the way this looks. Right? Positive a values, negative a values. So you get your min if it's right side up, or max if it's upside down. Okay. And then for part 3, I made up the numbers in front. All right, I chose 1 and 3. I just picked those, doesn't matter. I just had to pick positive numbers to make it a minimum. I had to choose negative numbers to make it a max. So I chose -1, -100, or -1,000. I chose 2 to make it, open back up again. But these are pretty set, right? Those vertex values, 11 and 0, right? 0 and 5, right? Those are pretty much set in stone. So pick whatever a values you want. Call them whatever you wanted. B, C, P, M, and Z is what I chose. Doesn't matter what letters you call them. I just picked unique ones. Sometimes I'll spell stuff out with them and see if people know this. Seriously, on my pre-calc test, I had 4 functions: M, A, T, and H. The one before that, I had 5: R, O, S, I, and E. So call them whatever you want. But hopefully that went okay for you. And if it did, great. If it doesn't, let me know if you have any questions. Anything? All good? So sweet, let's move on. I'm going to turn this one off. I'm not going to record this one because I want it to see the camera more than anything else. But I'm going to pull out my calculator to use it as much as I can to help. So if you have a calculator, even just your phone, that's fine. I just want you to be able to do some quick arithmetic. You're not having to do a lot of stuff in your head. But we're just going to look at some functions. Right? We're going to look at quadratic stuff. I'm still looking at these things that have x squared in them. Let me take you. with me. And I'll kind of do what I did last time. I'll write the general stuff over here on this board. I will write the examples that we'll actually do on the next one, okay? But you're going to want to write this stuff down, okay? Because my understanding is, I bet the things that I show you today, although not very complicated, might be new. They might be things that you, like, by the end of today, you're like, oh, that's super easy. But by tomorrow, it hasn't made its way into the long-term memory yet. And you're like, I don't know what I'm supposed to do for this homework. And you go back to today's work and like, oh, yeah, okay, super easy, got it. So it might be new to you. I think it would be good to write down what we're doing here in section 2.2. We looked at vertex form last time. Let's look at standard form this time. So I know it's a little glary up at the top for people watching at home. That says 2.2 standard form. And the reason they call it standard form is because this is the one that we're probably going to see most of the time. When they give us a function to look at, it's probably going to look like this before it looks like anything else. They're not going to give it to us in vertex form a lot of the time. We might actually have to put it in vertex form to do what we're doing. They're going to write it in standard form a lot. Okay. And when we talk about standard form, it's pretty true no matter what kind of function we're looking at. They just put the biggest exponent first and then go down from there. Like no parentheses, no nothing. They get rid of all that stuff. They multiply everything out. So you've got just term to term to term to term, biggest exponent first, and then the next one, and then the next one, and the next one, and the next one, and the next one, however many there are. Because it's quadratic, the biggest exponent is only a 2. So we're going to have an exponent of 2, then an exponent of 1, then an exponent of 0. That's, okay. Now I could call this whatever I want. I guess I'll just call it f of x. But in general, so leave a little space here for a second. You'll have an x squared term plus, leave a little space here. You'll have an x term plus, leave a little space. You'll have a number at the end. Okay, but leave a little space here because we're going to give them some letters, just like we did last time with A, H, and K. We've got 3 spots here. We're going to have to pick some letters to do that. Okay. Remember, letters at the end of the alphabet are for variables. Letters at the beginning, that's what we want to fill in. Letters at the beginning of the alphabet are for those unknown constants that from function to function won't change. Or sorry, within one function, they won't change. So we can kind of pick whatever we want. Okay. What was the letter at the beginning of vertex form? Do you remember what came right after the equal sign? Hey, it's the same letter in this one, because whatever that number is in vertex form will be the same as this number here in standard form. Okay, they're going to be the same number. So I could write a function in standard form and in vertex form. It'll give me the same graph, and it definitely has to have the same a value if they're going to be the same. Okay, but these next two are not h and k. You cannot see the vertex from standard form. You can see it from vertex form, right? So I'm not going to use h and k because there's a really good chance that those numbers will be different. They're going to mean different things, okay? So this is where we just go A, B, and C. We just pick the first 3 letters of the alphabet, and those are really just placeholders for numbers that'll show up in this thing somewhere. We'll actually look at functions that have a number for A, a number for B, and a number for C. But that A is exactly the same. This one right here is still that vertical stretch or compression. It's that reflection, right? If A is positive, we open up. If A is negative, we open down. That is still all true. Guaranteed. Okay, nothing about what we saw last time with A is any different, and that's why we're using the same letter. The same number does the same thing. Okay, but B and C are different. That's what I want to kind of explore today. It's like, what does B do, if anything? What does C do, if anything? And how can we figure out some important points along the way? Okay, you come with me to the board so we can just kind of play around a little bit with some options. Okay, you don't have to write this stuff down at all. I just want you to kind of look and watch what happens as I mess with A, B, and C. I don't know, whatever. X squared plus 4x minus 1. Don't write it down. Just look. Just take a look. see if we could figure out anything about A, B, or C, and where those numbers show up along this graph somewhere. And you can see the important points that Desmos already plotted. X-intercept, Y-intercept, and the vertex. All right, those are really the only points we'd ever need. We can always fill in the gaps around it, but we definitely need those 4, if there are 4. Now, I'll like do another one, so maybe we can start to kind of juxtapose the two. I don't know, like negative 2x squared plus 6x plus 3. Anything stand out about a number from the blue one that shows up as a point, or a number from the green one that shows up kind of in the same spot? Like this. Like we know what A means, and it's still the same thing, right? Positive 1, cool, opens up. Negative 2 opens down, awesome. So that's still good. Is there anything else that you notice? I'll do like one more. I don't know, like 3x squared plus 5x. I don't know, like minus 4. Let's make it like red, make it stand out. I don't know if it's any better. You see anything? I don't know if having too many of them is too confusing. Let's just do one. Any numbers in the equation that match a point? Okay.
So that number is on the y-axis.
So this number, that negative 1 right there, is that y-intercept right there? All right, let's see if that holds up for the next one. So here it is in green. So the last number 3, is that the y-intercept? Yep. The last number here, negative 4, is that the y-intercept? Absolutely. And look what that y-intercept is. Look what the x value is at that y-intercept. 0, 0, 0, right? If you're on the y-axis, you haven't moved left or right from the center, from the origin, right? So imagine plugging in 0 everywhere. Here, here, and here. That's the only thing left is that number, and you're exactly right, okay? We don't have to do any work to figure out what the y-intercept is going to be. It's just whatever that last number is every single time, which is really nice, that we have something that we can really kind of guarantee ourselves of. This right here is the y-intercept, okay? And if you write it as like 0, comma, whatever that number is, called C, cool. Or you can just say 1, negative 3, 5. You can just write the number, that's fine. Because if you say y-intercept, I know you're on the y-axis, and that's all I really care about is how far up or down do I need to go. Sweet. X-intercepts really can't tell. I'll let you know that right now. Not until 2.3. Okay, we can't do that just yet until we get into 2.3. But there is one thing that we can figure out. But it takes a little bit of work. Okay, and that's the vertex. Okay, and since we know a little bit about the vertex already, it seems like kind of a good transition to get us where we need to go. Okay, the vertex is a point. Now I'm writing this point really big right now because this is just in general. But when we actually do it, it'll just be numbers. So it's some number for x, some number for y. Okay. Now, how do we do it? Right, because h and k are not in there. And that's what we're trying to figure out. What is the h value? What's the k value of the vertex? This is where a little bit of work comes in to get there. And like the math that's happening in the background for what I'm about to show you, I can't show you yet because you won't get it. Okay, this is like 2.4, 2.5, 2.6. We look at this process and how they came up with this shortcut. I'm gonna give you a shortcut right away. It wouldn't make any sense. I think I would just confuse you more if I went through that process. So I'm gonna save like the proof for why the shortcut works until we get there. I'm just gonna give it to you right now, okay? And it really just has to do with A and B. Okay, C did its job. It gave us the y-intercept. A and B are going to do a little work for us, okay? The x value of the vertex is the one I can figure out using some relationship between these two, okay? That relationship ends up being a fraction to start. Now, that doesn't mean it's going to end as a fraction because, like, 6 over 2 is 3, right? It doesn't end up as a fraction just because I start with a fraction, okay? Again, I would prove this to you, but I think it would just be more confusing. I hope you just let me tell you what the shortcut is, okay? If I can figure out what A, B, and C are, I know what C is going to do. Really, I just want to know what A and B are, but I like to kind of start with that. I'm going to write down, like, here's A, here's B, here's C, to help me do all of these things. Find the y-intercept and then find the vertex. Here we go. Here's the vertex, okay? Negative B goes on top. So whatever B is, gives me the opposite. Now, so I say negative out loud, but I really just mean the opposite of B. So like if B is 2, then this is negative 2. If B is 10, then this is negative 10. If B is negative 4 already, then this would be positive 4. Switch the sign. Okay, so I know I say negative, I really just mean the opposite of. Okay, that's the top every time. The bottom of this fraction every time is 2A. 2 times whatever A is. Take A and double it, and that'll go on the bottom. Guaranteed. Okay, I could prove it to you. I think the proof is more complicated than obviously the shortcut. So I'm not gonna. I'll save that for when we're ready. Okay, that's the x value, no matter what. Guaranteed. Okay. How do we figure out if I know an x and I've got a function? How can I figure out the y value that goes with it? This, I know what it is. Negative b over 2, I just plug in those numbers, see what I get. Boom, 7. Maybe it's 7, okay? Where could I put that 7 to figure out the y value that goes with 7? On this function. Good try, though. I like it. Yeah, not C, because C did its job already. Right, so I know, like, so I have this x value. Here, I'll do like a first one, okay? F of x equals x squared plus 4x minus 2. Just make it, whatever. Do this one with me. Let's call this the first one, and we'll kind of build our general idea from here. So before I do anything, and this may be a little extra, but it's early on, so I'm just going to do it anyway. I like to just kind of come off on the side and just write down, here's what A is, here's what B is, and here's what C is. Because I don't care about the x squared or the x. Right? A is just a number. B is just a number. C is just a number. It just depends on where we're looking. Okay, so A is that number in front of x squared. And if I don't bother writing it, what is it? What is this invisible number right here? 1. Okay, if you have that term, but there's no number in front, it's a 1. Okay, B is the number in front of x. So what's that number? 4. Good. And then C is the number at the end. Negative 6. Good. Keeping track of the sign in front. Okay, good. Now, maybe you do that, maybe you don't. That's fine. I'm telling you what, we're going to use A, B, and C more than just in 2.2. We're going to use it in 2.3. We're going to use it in 2.6. So I like to. So let's do the easy one first. Where is the y-intercept? Guaranteed, right? I don't have to do any work. I just have to pick out that last number. And if you write it like 0, negative 2, cool. If you just say it's at negative 2, that's awesome too, because you told me y-intercept, so I know x has to be 0. I like to write my points as points, but either one's fine. Okay, vertex. Now, I don't know what's going to go in either of those two spots yet. But what I do have is a nice shortcut for how to figure out the x. So I know that x is negative b over 2a. If I could just drop in B and drop in A and see what happens, I'll have X. And I'll know exactly where this graph takes a turn. I just don't know up and down just yet, but I will know left and right. Okay, so if B is 4, what's negative B? Negative 4, so just perfect. And then 2 times whatever A is, that's 2 times 1. Right, because there it is. Okay, so negative 4 over 2. A negative divided by a positive when the signs are different and you're multiplying and dividing. Negative divided by a positive, is that negative or positive? 50-50. Negative. If your signs are the same, positive. When you're or multiplying or dividing. When the signs are different, it's negative. And then what's 4 divided by 2? 2. There it is. Like, I know that this is the x value of the vertex. Guaranteed. I know for sure. And I've got graphs that can back it up too. I'm telling you, if you're not like plugging these, like you get a function, if the first thing you're doing isn't plugging this in the calculator, you're missing out. There it is, -2 for sure. But that -6, how are we going to figure out if this is my function and I know the x value of some point on the graph? Where could I drop that -2 to figure out the y that goes with it? Plug it back in for all the x's. Remember, f of x is really just a fancy way of saying y equals, right? This is the rule that give me any x you want, this is what I want you to do to it, and that's going to give you the y value back, okay? So if you want to know what the y value is, like plug in x back in, right? Sub in x into the function and see what you get. So that's what I'm going to do. Okay, I'm going to say, okay, I don't want just f of x anymore. I want f of a very specific f. This is good for all. I know which one I want to look at. I want to see what happens at -2. So look, f of x, f of -2, right? X changed to -2 because that's what I want. I want to stop at -2 and see what I get, which means wherever I had an x before, right? Look at this function. Wherever there used to be an x, now I just drop in whatever number I just got. Whatever number I found from doing -b over 2a is the x value. I just want to plug it in and see what happens. And I let the math happen. Okay, we'll take our time here. But in general, I'm going to let the calculator do most of this work. We're not solving anything. I'm just substituting and seeing what's happening. So I'm going to go down. Order of operations. Anything inside the grouping symbols? No, it's just single numbers in there. So we're good. Exponents first. -2 times itself. +4. Now be really careful. If you type this in the calculator as -2 squared, like that, versus -2 squared, the calculator reads the negative sign as -1 time. This is that. The calculator knows order of operations. It's going to do exponents first and then multiply. And we know that that's not true. I know that -2 times itself is +4. So be careful when you type this stuff in the calculator. Always put negative numbers in print. Okay, -2 squared is 4. Okay, what about a +4 times a -2? -8, good. Signs are different, so the result is -4 times 2. And then bring down the -2. Good. Exponents done and multiplication done. I did them kind of both at the same time there. And then from left to right, 4 minus 8. So starting at 4, subtracting 8. Good. So -4 and then -2 more. -6. And there it is, right? -2, -6. There's the y value. Oops, -6. There's the y value. That's all. Okay. Realistically, though, This is Algebra 2, not 7th grade math. I don't need to see every little step of arithmetic. What I want to see is you just typing in, or I want to see you write down this substitution. Like write this part down, right? Write down what I kind of had in purple here, and then just give me the answer, right? Give me this for sure. I've got to see the substitution, and then jump right down to the answer. I'm cool with that. Done. Did it. Okay. Negative b over 2a. Plug it in. See what you get. That's what it's all about. Okay. I know it's hard to believe that that's exactly the case, but I promise. If you really want to see the proof, it might go over your head to start, but if I teach you 2.5, it'll make a little bit more sense. So I'm going to just wait till then. All right, cool. Let's do another one. I want to do the same ones that I did last time now. So I just make these up on the spot, but this way everybody that's home, doesn't matter the cohort, doesn't matter the period, they get all the same stuff. Okay. All right. Number 2. I used f of x already, so I'm going to make up a new letter. Pick one, please. D. Nice. D of x. Let's go 2x squared minus 8x plus 5. And let's say the two things that we can figure out, the two things they ask us for are the y-intercept and the vertex. Now what I like to do, and I don't think you have to, but I'm a really big fan, especially early on, going A equals, B equals, and C equals, kind of off on the side. Just so that I'm pulling out the numbers, and I don't care about the x squared, because it's not that A is 2x squared. It's just 2. It's just a number. By saying that it's A, I know what it's connected to. I know it's connected to the x squared. Okay, so A is 2. What's B? Negative 8. The sign in front, got to bring it with me. And then C? Cool. Whatever that last number. Okay, so what's the y-intercept? Perfect. That last number. I don't have to do any work. And you can just say, you can just write the number. If you want to write 0, 5, even better. I like that even better, but you wouldn't lose points for just writing the number. As long as you label it the y-intercept, then I know what you're talking about. Okay, but the vertex, I don't know. Just by looking. Not like with vertex 1, where it was just staring me in the face, and I just had to change the number on the inside and then keep the number on the outside. Here I have to do a little bit of work, okay? So that's where this negative b over 2a is going to come in, and that's what you're going to have to remember. Now, we're going remote, obviously, for the rest of the semester, starting at the latest after Thanksgiving. Okay, it might happen before that with new positive cases already coming in today. So that means your final, any work from here on out is all going to be remote. Okay, so you'll have notes and calculators and stuff to help you. So make sure you have good notes, and this gets a whole lot easier. Okay, so if b is already negative 8, what's negative b? It's weird because I call it negative 8 or negative b. It's the opposite of b. So if it starts positive, let's make it negative. If it starts negative, switch it, and let's go back to positive. So this is actually a positive 8 up here. Because really what's happening is this. Negative, negative 8. That's really what's happening. A negative times a negative gets me back to being positive. So just switch the sign up top, and then on bottom goes 2 times whatever a is. A just happens to also be 2. That's okay. And so we've got 8 over 4, which is 2. And that's what I like. I love when these things work out really nicely like that. And they don't always, right? We might get some decimals and some fractions. That's why the calculator is going to be so important, because I don't care about your like fraction arithmetic skills. Adding, subtracting, multiplying, dividing fractions is something that has driven students crazy since like the 3rd grade, and I get that. So I want to let the calculators do the work, okay? But now that I've got it, now that I know what x is, now I want to use it. I want to say, well, I can't say f of x. This is d. So d of. But I don't want just any x. I want a very specific one. And so I want my notation to show you, I'm not just like, not d of x. I know which one I want. I want d of 2. And so if you're actually going to plug in a number in for x, make sure you do it first, right there, right at the beginning, okay? And what that tells me is that everything that was an x is now going to disappear and be replaced by this number right there. That 2 goes in for x right there. And really, like, plug it in and see what you get. But just so you see what the arithmetic looks like, so you get better with it, okay? Nothing inside the grouping symbol goes together. It's just something inside. Okay, just exponents first. The only thing that's being squared right now is the x. This 2 is not. If they wanted that 2 as part of that square, they would have to put parentheses around that to keep that inside. So you need to square everything. They're not going to do that. They're going to keep that 2 on the outside. So I just square this. 2 squared is 4. If I was going slow, that's the only step I would do. Then I would do my multiplication and division from left to right. 2 times 4 is 8. Negative 8 times positive 2 is negative 16. Bring down the plus 5. Negative 8 plus 5. Negative 3. But seriously, like, just go like this. Just do that. All right, work straight across or straight down. You can work vertically. That's cool too. You can kind of skip the stuff in between right there. And done. And man, if you are not plugging this thing in and making sure you did it right, because you've got a graph, might as well just look at it, make sure you got it. You know what the answer is going to be if you're doing it right. Negative 8x plus 5. Boom. There's my y-intercept, 0, 5. There's my vertex, 2, negative. It's going to work every time. The other thing that's pretty nice about this number will always be twice as big as this one. This number will always be twice as big. That helps me. I feel like I'm doing it right. If I found the vertex, if my result here is twice as big. Seriously, like that's it. Like that's 2.2 is 2 things. All right, let's write it in standard form. Let's pull out the y-intercept because it's right there. And then let's find the vertex. This is the algebraic side of things. So really, like, just what's boxed in, that's what I want to see. I want to see this and okay, this is a little bit extra. That's cool. And of course, obviously the answers we want to box in too. But doing out the arithmetic, that's up to you, right? Writing down A equals B equals C equals, that's up to you. I like this a lot. It saved me and a lot of students a lot of trouble. Because like they forget the negatives or like things are in a wrong order or something crazy like that. So, I just want to give you a few to try. We'll just make sure you can do it and then we'll call it a day. I think we're doing pretty good right now. So let me bring some of these books over. I'm going to make up, I don't know, like 3 of them. See how you do. I'll give you a few minutes to get out in front of me. And we'll be done. I want to do the same ones I did last time. So, about 3, 4, and 5. 3, 4, 5. Let's see. We'll go A of X, B of X, and C of X. All right, x squared, not the first one, plus 6x minus 10. And let's find the y-intercept and the vertex. 3x squared minus 12x plus 8. And negative 2x squared minus 10x plus 11. All right, try those. I'll give you a minute or two. Find the y-intercept, just write it down. Find the vertex, find that algebraically. I'm just going to do a little bit of work to do that. Let me get some water. I'm going to graph these first. Why not? I just want to make sure the algebra proves whatever I just figured out. Minus 11? All plus. I'll just do blue and blue. Blue and green. Like Desmos is so great. You can get tables of values. I mean, it's all right. Oh, all right in one spot. So nice. Let me do one other thing. All right, let me put up the first one. This is what we'll build towards now. This is green. Negative, 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 negative 9, negative 19. There's a blue one down there, negative 19. And your negative 10. Crazy. So nice, though. So nice. We have a really nice shortcut. There is a long way of like going to vertex form. I'll show it to you. If you can find a vertex, then you know A already because it's that leading number, and you know H and K. This process won't be nearly as hard as I'm going to make it in 2.5 when I show you how to complete the square. Does that ring any bells? Algebra 1, I don't know if we ever did it. More of an algebra 2 thing. I'll still show it to you so that you've seen it. But I like this way better. Use a shortcut. There's H and K. H is negative 3, K is negative 19. Perfect. I know what A is. It's the same A. And I'm done. So there's the work that I'd like to see for questions like this. Really anything less than that, probably going to lose you some points. I've got to see that you know it's negative B over 2A. I have to see that written down somewhere. Then drop in the numbers and tell me what you get. Maybe you can, do negative 6 over 2 times 1 and just go right to -3. That's cool. But even for the, the y value, show me you know how to plug it in, how to write that down. A of -3 equals. Right? If you call that A of x equals there in that brown color, but you're changing x, then something's wrong. Right? A of x has x's in it. A of -3 has -3's in it. A of 5 has 5's in it. Got to see that good function notation. Is that first one okay? You see that? Is that all good? Okay. I mean, I hope it's relatively easy. Obviously, you don't know where the -b/2a comes from, but that's okay. It's really just about being able to use it right now. That's the most important. Oh, also, I cleaned up the beard a little bit, so you can see like the next level with just the handlebars. Nice and like it's like super soft now because it's so long. But I had like 2 minutes this weekend. I was like, I'm just gonna do it. And then Wednesday, I'll come in like actually looking like myself again for the first time since, I don't know, August. And then we'll see what happens. We'll see what happens with these few weeks. Honestly, it's whatever's best for the world. You know, if we have to shut down, then shut it down. I mean, obviously doing everything we can to keep businesses open and alive. I think it's going to keep the economy moving forward in a better way than if we completely shut it down. I would hate to see big companies thrive and small businesses suffer. I think it should be the other way around. You know, when you guys do your Christmas shopping, shop small. Try to keep the people in your community that that have these businesses, keep them alive. That's their livelihood. All right, let me do another one. Let me switch colors though, so you know that I'm doing the next one. Just a number, that's fine. I don't need the whole point. With vertex though, I do need the point because I don't know what x or y are going to be. But I am going to write down A equals, B equals, C equals. Keeping track of the sign in front, really important. And I like to say, all right, -b/2a. I'm just going to write that part down so these numbers are coming from somewhere. So if B is already negative, -12. Then if this is -b up top, I have to switch the sign and call it positive. B of 2, not B of x anymore. I have a specific number that I know is going in. Everywhere there's an x. It's substitution, so I'm still going to use parentheses, just like we substituted with linear systems. This is just even easier. It's just a number now. I don't have to worry about x's and y's and stuff. It's all numbers. And seriously, plug it all into the calculator and see what you get. Or do it out the long way. That's fine too. All right, 3 times 4. 12 minus 24. There it is. This one's twice as big as this one. -4. Or just do it like this. I just need to see what's boxed in right there. -4. But I'm hoping that you already knew that because you graphed it and looked at it. And there it was. Point right there and a point right there. Got it. Not a whole lot of work to do. 5 is a tricky one because the numbers aren't quite as nice as we might hope for the vertex. That's okay. 0, 11. A, B, and C. A is -2, B is -10, C is 11. C has done its job for the y-intercept. Vertex, I don't know. I'm going to have some work to do. Let's do it. All right. -b over 2a, so 10 over 2 times a, -2. Okay, so +10 over -4. Obviously, it doesn't go in evenly, but I'm hoping for like a nice decimal or something. Okay, nice. That's not too bad. All right, -2.5. That could be worse. -2.5 is fine. If you like the fraction version, -5/2. Fine too. Just divide both of these numbers by 2 to simplify. But I like the -2.5. That's a good one. If your decimal has an end, remember, you can use it. If your decimal doesn't have an end, like 1.33333 forever, then you need to use the fraction. And just plug it in. And thank goodness for calculators, because there's no way I'm doing this by hand. -2 times -2.5 squared minus 10 times -2.5 plus 11. Just straight in the calculator. I'm going to let it do all the work for me. -2, -2.5 squared minus 10, -2.5 plus 11. There we go. 23.5. If I typed it in right, and it should be right, and I should be able to check it. It's the green one. So I go to my green one, I look at it, bam, there it is. Beautiful. All good. This is the work I want to see for sure. There's my final answers. The arithmetic one step at a time, that's up to you. That's on you. A equals B equals C equals, that's up to you. I like it. You don't have to. You might get to the point later where you don't need it, but right now you do. That's fine. It's just a nice thing to be able to write that down. Again, drop the x squared when we're talking about A, B, and C. It's just the number. That's why we call them 3 different things, so I could tell them apart just by the letter without the x squareds and without the x's. All good? Not too bad, right? Just negative b over 2a is really the only thing you have to remember. And hey, I mean, how much do you really have to remember when you're sitting at home in a few weeks taking this final that's probably multiple choice and probably open notes, right? Now, when it comes to multiple choice tests, I always accept like partial credit on work if you show work. So what you'll probably see is I'll do the final virtually if things go the way that they're going to go. I'll do the final virtually at a specific time where you have a certain amount of time to get it done so that we're all kind of in the same playing field. But whatever scrap work you do, you'll take a picture of that and upload it to Canvas in addition to you just submitting the multiple choice test itself, so that if you get a question right, good, you got it right. Well, you get all the points. But if you got a question wrong, I'll go back to your work and I'll see if you showed anything good. Like maybe it was this kind of question and you did everything right except, you forgot the negative, something like that. And you got the whole question wrong because of that, right? Because you know on a multiple choice test, like if the vertex is 2, 3, you know 2, -3 is going to be there and -2, 3 is going to be there, right? Those are always the kind of questions they put on there to see how closely we're paying attention. But if you did all the right work and the question's out of 5 points, I can give you 4 out of 5, right? I can give you most of those points back for sure. So that's kind of what I'm thinking. I'd like to do, get to a point here a couple of weeks from now where we stop with however far into chapter 2 we've gotten, maybe even all the way through. I can give you one last chance for a grade that goes into the grade book before we get to the final, so that the final has less of a chance to destroy you if it doesn't go well. But we'll cross that bridge as we get to it after Thanksgiving. But your homework for tomorrow will just be questions just like this. I'll throw up some functions there. And kind of build all of it together, right? Because we can tell if this thing is a min or a max, right? Oh, A is positive, goes like this, it's a minimum, right? Done. A is positive, okay, it goes like this, it's a minimum. A is positive, it goes like this, it's a minimum. Oh, A is negative, it goes like this, it's a maximum. It's the same A. So all that stuff from Wednesday, is all coming back for us to be able to use. Cool. There you go. So check Canvas tonight-ish. But certainly tomorrow I will have homework 2.2 for you. That'll be due Tuesday at midnight. But you're looking at it. It's literally the same questions. I'm just going to mix up the numbers. And I'll probably put one on there that's got a decimal like that. Maybe one that has to be a fraction just to push you a little bit further. Because who cares? They're just numbers. They're all good. Let the calculator do the work for you. And we're good. Have a good day, everybody. I will see you hopefully Wednesday. Fingers crossed. Thanks, everybody. Any questions at home? Down, thanks for being here, bud. I will see you guys next time. Later.